Okay, so let's lock the meeting. All righty, can you see the screen?
Yes, ma'am.
Yes, ma'am.
All right. Please mute, guys. I know some of you are at work and wherever you are, so most definitely there will be noises behind. Okay, let's close this assignment. Close uni, sir. Alrighty. Now, this is more of like an application of partial derivatives. Okay, more of an application of partial derivatives. Let's go and see what they say. And rate of change. What is small increment, guys?
Like, you mean the theoretical definition or the mathematical one?
No, let's say when someone says there was a small increment.
Oh, the small increase, like it goes
A little
up.
change.
Yeah,
A little change. And normally when do people say there's a small increment?
And me, I use this thing too much in C++.
No, in their
you can't really notice the difference.
Yes, in their salaries. Have you ever someone said there was a huge change? They always say it was just a small increment. So, meaning that there's a small change in something. And then what is the rate of change? Rate of change. So that maybe we understand each other. We understand what a small increment is. If there's a small increment in your salary, then you know there's a small change in your salary. And then what is the rate of change?
Isn't it the I don't know, the definition given it, the rate of change, like how drastic or minimal something changes. Like, I don't know if to give a better explanation.
To the degree at which it changes?
Yeah.
Isn't it change per a certain period, like per time? Let's say like that.
Thank you.
A certain period.
It's a change per time. So the rate of change per time. So the rate at which the spread of COVID-19 was happening, the rate of what? It's the change with respect to time. So the small change, look, can you please, small change, ne? It's just an increase, small increase or small decrease. Are we all together? The rate of change, it's a change, it's the rate at which something is changing with respect to time. Are we together?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So outcomes. At the end of this learning unit, you should be able to determine a small change and find the rate of change. That's what they're saying. So now they're saying, consider the volume of a cylinder of radius r and height. Okay, so now when it comes to small change, okay, I think I'm going forward. Let's read first. Consider the volume of a cylinder of radius r and height h. So we know that the volume is equals to pi r squared. We know how to find the partial derivative of v with respect to r. We know that, right? Where h is constant. We saw that we can be able to do that from the previous work.
Yes, ma'am.
Yes, ma'am.
Same as the partial derivative of v with respect to h, with keeping r constant. So there, when we're doing partial derivatives, we're keeping the other one constant. And when you're keeping the other one constant, what does it mean? It means there's no change of anything. Does it make sense? So
Yes,
whichever is kept constant, it's not moving, it's not decreasing, it's not increasing, it's kept constant. But in real life, does that really happen?
No.
Where you can
No.
control one variable and the other one you don't control.
No,
It doesn't.
the input.
Do you see that? Meaning that if a function has more than two variables, z is equals to f of x and y, at some point you can't be able to change to keep one constant. X and y can change at the same time. So they say, but what happens if both of them, r and h, changes? Right? Now they say if r becomes r plus a small change in r, and h becomes H plus a small change in what? In H. Let V becomes a small, what's this? V plus a small change in what?
In
In
V.
V. Then the new formula becomes this. You don't have to simplify that. You don't have to know it. But at the end of the day, they are saying that from these formulas, you can go and read. You can then be able to find a small change in V. How do you find that small change in V? You then say the partial derivative of V times the small change in R plus the partial derivative of H times the smaller change in what? In H. So meaning that if, for example, the volume of something, whether it decreases or increases, if you have a volume of, let's say 5, and then there's water in a dam and whatever, I just forgot the units for volume. But let's say you have 5, is it meter squared, cube or
Cubic
something?
meters.
Yes,
Cubic
cubic
meters.
meters. So let's say you have a cubic unit cube of something, and then there's a change there initially, whether it's a big change or a small change. I'm not sorry, it's a small change, whether the change increases or decreases. How do you calculate that change? This is how you're going to calculate the change, basically. So they say this result applies to any function of two variables, independent variable. Remember, Z is the dependent variable, independent variable is X and Y. So then you can apply that function. This also applies to 3 variables, 4 variables, 7 variables, and whatsoever. Right? Then the small change that has a function of X, Y, Z is then the partial of X times the partial of Z with respect to X times the small change in X, the partial derivative of Z with respect to Y, times the small change in Y, and the partial derivative of Z with respect to W times the small change in W, just to calculate the change. Are we all together?
Yes, ma'am.
Yes, ma'am.
So here's the question. Let's try this question. So they say a cylinder has a diameter of 100 centimeter and a height of 100 centimeter. Find the approximate increase in volume when the radius increases by 0.2 centimeter and the height decreases by 0.1 centimeter. Where do we start?
We should probably know the volume, well, the formula for the volume of the cylinder, which is V equals pi r squared h, but we're given the diameter instead of the radius. So the diameter is 2 times the radius.
Okay. Do we all agree?
Yes.
Yes, ma'am.
Yes.
Okay.
Yes.
Guys, why am I not also giving? So next time I should give class to the 4 people who are always talking. Because remember, it's a discussion class.
We are following, ma'am.
Maybe they're
But you
also
know-
shy, ma'am.
Yeah, you know, shy.
I was shy once, and look where not being shy took me. You see, you never know. You see? So that's why I'm saying, okay, why am I distracted? Because there's noise.
Taban, can you mute your mic?
Thank you. So now they say a cylinder. I mean, guys, my first years will know if there's a statement like this, I draw. I draw. What is a cylinder? What is the shape of a cylinder, guys? Give me an example of the shape of a cylinder.
A tin
Can.
can.
A cold drink can. I'll not mention the name because they don't pay me. So I'm assuming a tin can or a tin of beans. So it's like this, and the worst part is I'm not even good at drawing the way I like drawing. So this is a cylinder, a cold drink can. I'll call it the Stacia drink. So now the Stacia drink has a diameter. What is the diameter? Here at the top, we know it's from this point to that point, or from this point to that point. So they say this is 10 centimeter, right? And the height is 10 centimeter as well. But now they're talking about volume. So we know that the volume is what? Pi r squared h. Are we all together? What
Yes.
other information they gave us? They say that a cylinder has a diameter of this, meaning we know we're dealing with r. So meaning that r has the radius is what?
2 times, half a diameter.
So it would be 5 centimeters.
5 centimeters.
Divide.
5 centimeters, right? And then the height will be 10 centimeters.
Yeah.
Okay. Now they're saying that find the approximate increase in volume. So what are they looking at? The small change in V.
Yes.
So now, according to what we learned, the small change in V is partial of V with respect to R times the small change in R plus partial of V with respect to H times the small change in H. Now, do we know the small change in H? Not H, but the small change in H. Do we know the small change in H? And do we know the small change in R?
Yes, ma'am.
Yes.
Yes, we were given.
What is it?
Small change in R is 0.2 centimeters, and the small change in H is a decrease by
0.1.
0.1 centimeter.
Okay, sorry.
My heart doesn't want to continue. Why?
We must take the
Let's
height
continue,
and
ma'am.
minus
Let's
the
continue.
decrease. Oh,
There should be
My
a
heart,
negative on the H because it's a decrease.
well done. There should be a negative on the
Plus
H because
minus.
there's a decrease.
Yeah. Okay.
Are we all together there?
Yes, ma'am.
So there's an increase positive, there's a decrease negative. Okay, so let's go. We want a rate of, so we know that V is equals to pi r squared H. I am not going to find this. The partial derivative of V with respect to with respect to R. Which ones are we keeping here?
Pi and H.
Pi and H, what are we differentiating?
R, which will give us 2R.
And then we are in the same page. Okay. And then partial V over partial H. Which one are we keeping?
Everything
H.
but H.
Yeah, everything but H.
Then differentiate to get 1. Are we all in the same boat? This is very easy.
Yes, ma'am.
Same boat.
Yes, ma'am.
Thank you. Not the Titanic. I can't swim. Okay. So now we then go and substitute. So we then say partial V is equals to, we know this is 2 pi RH times the small change in R plus pi R squared times the small change in H. So then we know that, okay, let's remove the pi outside. So this is the pi. So we remain with 2. What is R, guys?
5.
What is H?
10.
What is the small change of R?
0.2.
2
0.2.
centimeters.
Plus, remember we have removed the pi there. And then what is R? We know R is squared times what is the small change? Negative 0.1. In the calculator, we have what? This here. What is there in the calculator?
Sure.
20.
20 way.
It's pi on the outside,
Pi
open
is
bracket
outside.
20.
Yes.
Minus
2.5.
2.5. So the answer is what? 17.5 cent. Okay, what is the unit?
It should be centimeters cubed.
Centimeters cubed, ma'am.
Are we all okay on centimeters cubed? Or you just like me?
Ma'am, you've got your pi.
Oh, yes. Thank you. Are we all okay, guys, on centimeters cubed? Or you just like me and like, huh?
If they
Okay.
attended physics, they should know conversions by now.
I attended physics. First year, I attended physics from grade 10. And sometimes I'm like, huh? Are we all okay with the units, guys?
No.
Yes.
Yes, because everything was given to us in centimeters.
So you just assume then the answer is centimeters cubed.
No, your r squared is centimeters squared and your h is centimeters. So you would be dealing with centimeters cubed in volume.
Okay, is there a no? If there's a no, I'm not moving on. You know that. Majority with
Well,
no, it cancels everything.
Well, I think
Ma'am, I'm saying
we
no
should.
on what you say that we assumed. So I was saying that I didn't assume, like we have the units there and we can see that we've got on the left hand side we've got centimeters squared multiplied by centimeters plus centimeters squared multiplied by centimeters. So that's how we got the centimeters cubed there.
Thank you. Are we all okay now?
Yes.
Yes.
Guys, if there's a no, me, if you become like my friend, I'm telling you, she used to ask questions every second. She didn't understand. Every second, she will ask questions. Now she's in Netherlands, a computer scientist who asked a lot of questions. If you don't understand, trust me, you didn't come with a friend. Even if you came with your twin to this module, if you don't understand, tell me. I shall show you. Alrighty. So that is a small change. Are we all okay with the small change?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All
Sorry,
right.
ma'am.
Yes.
Is it correct to assume that with the question like this in the small change, they will always tell us what the increase or the decrease of the independent variables?
Really? Because sometimes they might not look for the ink. Let me not tell you the answer. You'll see with an example. If I don't, if you don't get answered on this question, if you go back to the example, then remind me in one of the classes, in the last class next week, that I'll be with you guys. Not next week, man. You know what I mean. Isn't that we have that class that we need to cover? So we'll have two classes where we cover the questions that you asked, that you didn't understand on the study guides, and the last part of the section. So those are the two classes before you get into integration. So if that question is not answered, then come back to me, remind me, because you might have given me a clue on an exam question.
Okay.
Sorry, ma'am, just a quick question. On
Yes.
that final answer that we gave, which is 17.5 times pi, won't we finalize it by multiplying that 17.5 by that pi, since pi we usually know that is 14 point something?
You can do that, but in most cases, especially with this module, we check your understanding of the work.
Oh, okay.
More of your understanding of the work compared to the final answer. For example, if you did everything correct and your answer was 18 point what, out of 5, you'll definitely get your 4 out of 5. Because
Okay,
the steps, yes, it's the understanding, and you guys are engineers. We don't want you guys to kill us. just trust the cars will be fine. We trust the electricity will be fine. We trust the pipes won't burst. We're putting our trust in you guys. We trust we'll drink clean water. We trust the bridges won't break. So if you don't understand your work, then that's a problem. Alrighty, so let's look at rate of change. I almost stopped the recording because this is the part of the same section. Okay, so rate of change. We said rate of change has to be associated with what?
Change over time.
Over time. So if you don't see a T somewhere, then whatever you're doing is wrong, ne? Yeah? Guys?
Yeah,
Are
good
you
here,
here?
man.
Alrighty. So
We
meaning
hear
that
you.
the formula cannot be the same as the one we're doing for the small change. Do we agree?
Yes, because time wasn't in the other formula.
Dango. So let's go. They say the rate of change. Let us consider again the cylinder of a radius and h, the height. Then the volume is given by this. So then when we take the partial derivative of volume with respect to r, we then get 2 pi rh. And when we take the derivative of the volume with respect to h, we get 2 pi r squared. Now, since v is a function of r and h, we also know that the small change, right? The small change is given by that formula over here. The small change of v is given by that formula v. So now they're saying, if we divide both sides by small change in time, then this is what we get. Do you see that? So they're saying we divide everything with both sides. Remember you had a small change here? So we start here. This is where we start. And we divide by small change in time. Now they're saying that this, when you have a small change of volume divided by a small change in time, actually gives you the rate of change of volume. Do you see that?
Yes,
Meaning that this part will give you the rate of change of r. This part will also give you the rate of change of r. So then this becomes what? D of v over dt is equals to partial v over partial r times dr over dt plus this part partial v over partial h times d over of h over dt. So this is the rate at which the radius is changing, the rate at which the height is changing, and the rate at which the volume is changing. And because I'm very forward, Ngia Papa, I gave you the formula, which is this one. Are we all together now?
Yes, ma'am.
So they're saying the rate at which, what am I saying? The rate at which the volume is changing is then given by that. Oh, this thing is nice and easy. So meaning that if you have a function that has x, y, z, t, and whatever, then you have that the rate of change in u will be the partial. Can you see what it is, guys? Partial u with respect to x, rate of change of x. Partial u with respect to y times rate of change of y. Partial derivative of u with respect to z times the rate change in z. Are we all together in the same boat?
Yes, ma'am.
Yes, ma'am.
Okay, so let's go and do this example. I don't know why it's example 4 because the rate of change was the first part. All right. Come on. Let's do this. So the radius of a cylinder increases at the rate of, while the height decreases at the rate of. Find the rate at which the volume is changing at an instant when R is equals to and H is equals to that. Because I like drawing and I don't know how to draw, I'll just draw. So we know the radius from here to here is 8 centimeter. H is equals to 12 centimeter. You said you know the word. Give me the answers. What are we looking for here?
The rate of change of volume when R is 8 centimeters and H is 12.
Who's talking? Who's not talking, but who's disturbing us?
Sorry, ma'am.
Yeah, you gave me the answer you did. You give me the answer that you were talking. Please give me the answer. Guys, can we also have different because one day me I'll just call the person who's participating in class and have a class with them and no recording.
Ah, that sounds nice.
You see?
So remember, what was the question so that I can answer?
Here's the question in the board. On the screen, I mean. Hey, yeah, the board. Hey. On the screen. Here's a question on the screen. Help me. Break the question to a point where I know how to do it. Or we know how to do. Let me not say I know. Me
Okay,
doesn't.
so here, right, we are given the rate of change of what? Of the radius, number one, and then of the height, of which we of which it is said that the radius of the cylinder increases while the height decreases. Then they're asking us to find the rate at which the volume is changing at an instant when R is equal to 8 centimeters and H is equal to 12 centimeters. So the first thing that we do, we write the equation for volume of a cylinder, which is V is equal to pi R squared times H. And then from there, we do the partial derivative of V of, yeah, the partial derivative of V over partial derivative of R.
Which is equals to?
Which is equals to 2 pi RH.
Okay, then?
Then we do the partial derivative of V over partial derivative of H, which is pi R squared.
Okay, then?
And then from there, we will use the equation that you showed us few moments ago, whereby it says the rate of change,
like this.
Wasn't it d V over dt, ma'am?
Okay. Remember, you are writing an oral exam. dv over dt
is equal to 2 pi RH.
Formula.
Okay, sorry, ma'am. Partial derivative of V over partial derivative of R.
Yeah.
Multiplied by the rate of R. Plus
over, I think. Over.
Plus partial derivative of V over partial derivative of H.
The same above, yeah.
Multiplied by the rate of change of the height.
Of the height. Over rate of change.
Is it okay? Does it look okay?
No, I don't think so.
Why?
It should be divided.
Should be by dt.
dt, ma'am.
dt.
Thank you, because it's the rate of change. So dr over dt.
dh over dt. Yes.
Okay. So where's, because I don't see that where's dh and dt here? I don't have it. dr over dt, what is it?
It's positive 0.2
Positive 0.2.
centimeters per second.
Okay, and then the h over dt is negative, I think. Negative 0.
It's
Negative
0.5 centimeters per second.
0.5, yeah. Negative 2.
Okay, so what will be the units here?
Where?
Here.
Final.
I want you guys to give me the units. Isn't that you guys gave me the units before? Now I want you to give me the units before we even substitute. What is the units?
Centimeters per second.
Partial derivative.
Centimeters.
Final answer.
Yes, for the
Centimeters per
final
second.
answer.
Centimeters per second. Huh? Hey, I think so.
Centimeters
Rate of
per
change.
Square per second.
Centimeters cubed per
Centimeters
second.
A second and a cube per second.
Per second, okay.
Are we all okay? Can we
Yeah.
have more ladies, guys?
Yeah.
Ladies, are you okay with how we are finding these centimeters squared instead? Or you are just like me?
No, I agree. Centimeter cube per second. The last ones.
Okay. If you are okay, then me, I'm okay. Because if the engineers are okay, then
So, ma'am, I probably would have started with putting out the formula first, then checking what I have and what I don't have, and then starting with your working out of your partial V over partial R.
It's okay. It's okay. When we mark, guys, we look at what you did. Who said that dessert cannot be eaten first? You see, as long as you eat everything, and it's you. Okay, I don't know if it is a good way of eating, but that is okay as well. That is okay as well. So okay, let's go substitute then. So the rate of change of V with respect to T. So we know that that's the partial of, where is it? It's here. So that's 2 pi RH times the rate of change of, which is this one, isn't it? Do you agree?
Yeah.
Yes, ma'am.
Which is 0.2 centimeter over S. Me, I like doing it like this, guys. I'm not an engineer. You can write it with units because you know the answers. You can also write, you can just write here and the units. Me, I'll write the units inside. Is that okay?
Yes, ma'am.
Whichever is suitable, it's fine.
Yeah, me, I'm not an engineer, so please bear with me. So this is minus 0.5 centimeter over seconds. Because I'm a mathematician, I want the units to be right. So I know this is 2 pi. My R is in what? Centimeters, isn't it?
Yes, it's 8 centimeters.
8 centimeter. My height is in centimeters is what?
12 centimeter.
4.
12.
12 centimeter times 0.2 centimeter per second plus pi. My R is 8 centimeter squared minus 0.5 centimeter over S. So for me, I know, okay, let's put this to the pi outside, guys. So pi on this part. So when you have 2 times 8 times 12, what do we get? Times 0.3.
38.4.
So we have 38.4. Now centimeter times centimeter times centimeter is what?
Centimeters cubed.
Centimeter cubed.
Per second.
Cubed.
Times 1 over times that, so that is per second, plus pi outside 8 squared.
It's minus.
Yes, thank you, minus. Minus, there's a minus here, right? Then
32.
8 squared is what? Times this 32. So that's 32. And then because of this square, the centimeter becomes squared times another centimeter, centimeter cube over second. So then this is equals to, I'm assuming that's 6.4. So this
Correct.
is 6.4 pi centimeter cube per second. That's the rate at which the volume is changing. That's not the small change, but the rate at which the volume is changing. So is the volume increasing or decreasing, guys? Huh?
Wait, I didn't see the first
It's
volume.
increasing because it's
That's-
positive.
It's increasing,
Thank
it's
you.
positive.
Yeah.
Thank you. The volume is increasing because it's positive. And then I come and set such a question in the exam and say, I didn't teach you. Guys, that's what happened last year. All righty. Oh, then we can stop the recording.
What, we're done?
No, we're not. But we're done for this particular section. Any question for this particular section? So we look at the small change and the rate of change. Those are two different things. We know that the rate of change has to happen with time. So the rate at which animals are becoming extinct, it means over time. At the rate at which babies are growing, it means over time. Yeah. A small change means there's a small change in the salary. There's a small change in, not change as in like I buy and you give me change, but like, increase or decreasing, that type of change. Any question? If there's no question, I'm stopping the recording. Can I get a permission for stopping the recording?
Yes, ma'am.
Yes,
Go right ahead,
Uncle.
ma'am.
All right. Stop the recording.